Hello, everyone. Welcome to reInvent 2022. Super thankful that you folks have been able to come here. So thankful for that. Today, we're going to talk about how Riot Games processes 20 terabytes of analytics data daily on AWS. My name is Karthik. I'm a principal architect in AWS, supporting Riot Games as a customer. I've been in Amazon for 6 years, 6.5 now, and supporting Riot for 2 years now. We also have Wes from Riot.
I'm the director of tech research at Riot Games. So tech research is our R&D operation that partners between academia and industry and tries to push state-of-the-art technology for Riot. In a former life, I was also tech lead for data, which is why you have me here talking with you today.
Thank you, Wes. All right, so how many of you play League of Legends or Wild Rift? Nice, nice, awesome. Do you like the intro video that we did for the World's Finals presentation? Awesome, thank you. All right, so in today's presentation, we're going to do a brief introduction of what Riot Games as a company, the introduction on the company, the games that they offer, and then we're going to do a tale of 4 architectures. We'll talk about how we scaled telemetry data for League of Legends, preparing for the next wave of games that Riot was going to announce back in 2018, 2019. And then we're also going to talk about how they had to fix an airplane in flight, well, not literally, but an architecture that's already working in production. So talk about how we fixed the plane mid-flight. And finally, we're going to talk about our current state, which is the one event bus to rule them all architecture. So we'll go dive deep on all the 4 architectures, what were the design choices, what were the challenges, and how we arrived there. And then we're going to close out with what's next, like what are we looking at, what's in the horizon, how do we improve or create evolution within our architecture.
So to get us started, it's awesome to see how many people have played League of Legends, have heard of League of Legends, but Riot Games is the developer and publisher of League of Legends. It launched in 2009. We have over 100 million players playing monthly. And it has and over time, we've expanded our portfolio. So in the past few years, we've added a mobile version of League of Legends and League of Legends Wild Rift. We have a trading card game in Legends of Runeterra. Teamfight Tactics is Riot's take on the auto battler genre, and it's one of the largest strategy games currently out there. Valorant is our take at a tactical first-person shooter, and is a lot of fun to play if you're good at that sort of thing. And then lastly, Riot Forge is our publishing arm. So with Riot Forge, we publish games that are set in the world of Runeterra, which is the original IP that we came up with for League of Legends. We partner with smaller studios in those in order to sort of advance the number of games that explore our universe. We're not only known for our games, we're also known for some of our esports events. So we just recently closed up our esports World Finals for League of Legends in 2022. If you arrived early, you saw the video that Karthik was referring to. We just completed an amazing 2022. There were 2 of the world's best, Faker and Deft, who have been competing with each other since high school. They went to the same high school. Now they met each other on the biggest stage to compete for the World Championship. The games went all 5 games. It was an amazing series with Deft and their team just barely edging out Faker, who is widely regarded as one of the best players of all time. We also have esports up and coming and growing for our Valorant game. So we have the Game Changers Championship, and then we also run esports for Teamfight Tactics. So we have a world championship that our players play in there. So that covers a little bit about who Riot Games is. We're going to dive in a little bit here first and talk about how we took our first game, which was League of Legends, and went from a time period where we were scraping audit databases and really scaled out our telemetry for League of Legends. And I'll have Karthik walk through that initial architecture.
Thank you. So back in 2012, 2013, Riot had majority of their infrastructure back on their on-prem data centers. So players who were interacting with the League of Legends servers, the game servers, the microservices that made up their core ecosystem was running on their on-prem data centers. And so all the REST API calls, the microservices supporting these players, everything was on their game servers in their data centers. So the system that Riot created to simplify this gathering of this analytic telemetry data was called Honu, and this was run alongside their game servers, their microservices, basically all the services that were interacting with the players. So they also built a Honu collector right next to the Honu app. And what it did was it was periodically write out a file to S3 on all the data it has collected so far. So from S3, so S3 was the landing zone, and then from S3 it eventually went into the data lake. So from S3, it went towards EMR, and that's where they relied on for basically processing all the data that they got from their game servers. So if you talk about break down into separate tables, or make larger files, or basically store all the results by the hour, all of those workloads was done by EMR. And then from there, the data was consumed by data engineers, data scientists, and analysts who would then query the data both in S3 or Databricks running on AWS. Riot uses a ton of Databricks on AWS, so they used both the platforms to query the data. And ETLs were basically scheduled and orchestrated by using Apache Airflow on EC2. And on the downstream dependencies, we had analysts who are using Tableau to visualize and run reports and dashboards on that data.
Thanks, Karthik, for that overview of the Honu ecosystem. And for any of those who are wondering where the name Honu came from, it's actually a Hawaiian word for turtle. And so later in the slides, when you see turtles referencing for Honu, that's where that's coming from. Now, one of the key design decisions in this original architecture was a system to make all events schemaless. We did this to lower the barrier to entry for our engineers, to make them more comfortable with sending that data through and make changes to it very quickly. We also added no validation. So all of the events just flew into the system as they were, and if there was a bug in live, that data would come in corrupted. All of this helped adoption, and it helped really sort of move engineers into it, but it came with some costs associated with it. All messages were just strings or a pair of key value pairs of strings, and so they could stuff whatever they wanted into it. Now on the left, or on the right, we have a video, a little GIF of a first blood in one of the League of Legends games. And now first blood is the first time a player kills another player in the game, and that represents a good opportunity for an event that we should send into our telemetry for further analysis. Now, one of the good things that comes across in this event, the payload that you see below it, is we have this game ID. That game ID allows us to stitch together all of the events and recreate what happened organically in that game. We also have the killer and the victim, so the killer's account ID is associated there, as well as the champion in which they were playing when they got that first kill. Similarly, with the victim, we have the account ID and the champion ID they were playing. Now, this event that you're looking at doesn't actually match up with the GIF above, but you get the idea of this data is flowing through the system. And then when we have the XY position, we also know where the kill took place on the map. Now, this unlocks lots of different analytics workloads. We can actually sort of start looking at where people are dying on the map. We can look at which champions are getting the most kills, and you can start to do quite a bit with it. Overall, it's a pretty good event that gives us the ability to do more with it when players are killed and other analyses. But it also comes with some other things. So while we have the data we need for the event, we encountered other problems with schemaless. We often overloaded messages. As you see, there's a lot of empty fields in there, which means the data engineers had to actually come in and clean it up. So you had a lot of tribal knowledge to know, oh, on a game kill event, you don't actually look at these fields here because they're never populated. Additionally, you can start to see that they kind of stuffed additional data in there. So if you look at the victim field here, you'll see that they actually stuck serialized JSON as part of that string. And now, no one's telling us about that until you go to query the data, and now you got to look at it and go, okay, what do I have? Oh, that looks like it's JSON. Let's decode that JSON, now figure out what's inside. And all of that work is left downstream to the scientists, engineers, and analysts. But it did really allow those engineers to move quickly, add new telemetry to the system, and really sort of make it possible for us to scale. Additionally, we built the system so that it would lose data in the event that it was about to fall over. So imagine that these Honu collectors are sitting in the games inside our data centers. They're running alongside the games, and let's say League of Legends has a spike during Christmas when everyone comes in and starts playing League of Legends. And that spike may lead to the Honu collector recognizing that I'm having too much data, I can't write the data out quick enough to disk, I'm eventually just going to fall over. Rather than let the system fall over and rely on all the services and game servers to sort of hold that data in memory until that Honu collector came back, we would actually just start throwing data on the floor so that the Honu collector would stay alive. Now, this design decision is really around sort of that trade-off of, do you go and drop everything, or do you drop some of it and stay in that degraded state until you can recover? And then lastly, we have the many small files problem, which is the bane of many data ecosystems. So here we have all of these Honu collectors are writing small files out. They're uploading them to S3. They're quite small because we want that data to get up there quick. We want to persist it, make sure it's saved. And then that rely on that downstream aggregator to sort of group that data together into larger files so that queries are more efficient. This often puts in a further delay for teams trying to run analytic workloads on it and machine learning workloads, because they have to wait until the job that sort of does that aggregation has run and rewritten the new data that's more performant to query. So all of those challenges existed for the Honu ecosystem and worked with how we tried to roll this out and actually build out our telemetry pipelines. But it wasn't all bad. Just because there are some challenges with this first architecture doesn't mean that folks were unable to make some amazing things for players. And so this first example is Your Shop. So Your Shop is a store that pops up once a quarter, roughly. And in it, players come in, and they're given 6 unique offers. Those are champion skins that we think they would like to play, and they're at a discounted price. The system powering that is built on recommender systems. It's actually a quite old recommender system, so we're not pushing state-of-the-art there. But it's leveraging the data in this ecosystem in order to decide what champions and skins you would be interested in, based on your play habits and your purchase habits, and then sort of rank these skins in that order to make sure that we give you discounts on skins that you're excited to play with. We also provide additional analyst insights. So this comes from a blog post in 2017, where we worked with designers to sort of help them understand how players are engaging with champions in the game. On the x-axis, you have the breadth. So what this is the number of unique champions, or number of unique players playing a specific champion. On the vertical axis is the depth, and think of this as the number of times each player plays a specific champion in a given time period. And so in the top left corner, you have your popular champions. In this case, we're only looking at ADCs, which are sort of a high damage carry role. And those are champions that are played by lots of people, and when they're played quite frequently. In the lower right, we have those champions that are popular, or that are played by a lot of unique people, but each time they're not played as frequently as the popular ones. And then on the top left, you have niche champions. So these are champions that may not be played by a large number of players, but the players who play them absolutely love them. And although he's not an ADC, this is where you'd find my favorite one-trick Singe living up there, because the people who play him just love him to death. And then in the bottom left, you have the unpopular champions. So these are champions not played broadly and are not played by lots of players. And what the designers could do is take that information, go to try to revamp a champion, and see if they can move it into the quadrant that they wanted. And it gives them some sort of feedback on how well they've accomplished what they were trying to do with that champion. So as Riot prepared to move from Riot Game to Riot Games, we had an opportunity to revisit some of the assumptions of the first architecture, this Honu architecture. And we wanted to leverage newer and more robust means of ingesting our telemetry. This next slide is a high-level overview of our AP ingestion system, our analytics platform, that would power our new games launching and unlock new data opportunities for our players. A new assumption that wasn't true beforehand would be that our new game servers would be deployed on AWS infrastructure, allowing us to avoid the challenges of getting data out of our data centers and running on bare metal. And I'll hand it off to Karthik to walk us through that architecture.
So in this architecture diagram, you'll see the shift that Riot is making in moving their microservices and their game servers from on-prem data centers into AWS. So you'll see this trend of migrating workloads into AWS, and there's this unique opportunity to drop assumptions that they made when they had the tech running on the on-prem data centers. So if you look at right now, instead of having it in just a set of data centers, they started looking at, hey, can we look at deploying our game servers and microservices in multiple regions, right? Previously, they were looking at, hey, we have a central region. This is where all of our processing and back-end processing happens. And now, in the newer phase, they're looking at a more central and satellite region where they collect all the data from the satellite regions where it's closer to the player, reduce operational overhead, reliability as well. So all these factors in, Riot started expanding their game servers, their microservices, their APIs, all their ecosystems into regions around the world. So they created a new collector that would persist the data in Kafka. And once it returns a success to the producer, it would rely on Kafka Connect to take that data and replicate the message back to a central Kafka cluster, going back to the logic of a central and a satellite region. So what happens over here is it's no longer doing the heavy lifting in one location. Now we are replicating or reducing our dependency in one location and spreading it out. So now as the data comes into Kafka, the first thing it does is it demuxes the data from a single topic fire hose into individual topics and messages per its definition. So data is then pushed downstream into the Delta Lake and into the Hive metastore. So then it's pushed into Spark. It's pushed by Spark structured jobs, structured streaming jobs.
Awesome. Some of the new features that we had when the system was designed. So we wanted to address the pain that our downstream consumers of data felt with schema not being enforced and changing underneath us. So here, from the beginning, we set out to have schema built into the system. Here we leverage JSON schema for definition telemetry of the telemetry payloads, as well as for validation in the system. Now on the right, you can see one of our schema definitions. This happens to be for a Riot Forge game. And notice that there are no primitive types defined in this system. So as we built out our schema registry and our schema knowledge, what we wanted to do is have this semantic layer that would sit between the primitives and the actual payload so that we could do more with governance and understand better, more easily, what data was contained in those value fields. And so one specific example you can look at, and I spent some time trying to figure out why it's named this, but is RFC 0460 timestamp. I thought it would, when I went to look on the IETF for RFCs, the internet RFCs, 460 has nothing to do with timestamps. So I think it's our internal RFCs, but when I went to look at that, that was actually the AP definition. So whatever it was this is the internal timestamp definition that we can figure out what that means when I get back. But the idea is that we have experienced this in Honu, where we would have timestamps that could be the milliseconds since the epoch. We had timestamps that were string formatted in a certain way, and we had other ones that were formatted differently. And as a scientist and analyst, you would have to go in and sort of just inspect the data and try to figure out what they had done. So with that, we got rid of, with schema, we're able to sort of alleviate some of that pain point. As Karthik mentioned, we also moved to regional collection. We're writing directly to Kafka as our persistence layer in region, and then replicating that back centrally. So that gives us sort of quick response times for the game teams, with the confidence that those game teams know that that data is persisted and will eventually make it back into the data warehouse. We also unlock streaming capabilities. So we, in the architecture before, you see Kafka going through a demux and then into this Delta Spark structured streaming jobs. Those wrote to a data lake, and then teams could write structured streaming jobs that would come right off that Delta Lake and start doing more things in processing of that data. So this is our first steps into that streaming world, where teams can now be able to react much more quickly and build much more interactive systems on top of it. We also allowed streaming off the global Kafka if you knew the team well enough and they trusted you well enough to actually sort of hook into it. Since it has all of the data for every region and every topic, you're basically going to be drinking from the fire hose, which we'll see next. So some of the challenges that we face, as I just alluded to, all of our events are published on the same fire hose topic and then replicated back centrally. And enjoy the art as we go through. I had some fun generating this with Stable Diffusion, trying to get it to make meaningful things, and results vary. And so This meant in-region processing was still difficult because teams would either need to wade through all of the data in order to find the events they needed, or they needed to wait until it landed back in the central region and stream off of that. Another challenge that we had is replicating all your data centrally just to write to Amazon S3 carries a pretty high overhead and cost. So all data from around the world is returned centrally through one giant Kafka that we scale vertically in order to support it, and that is just to write to S3. So we'll talk, as we move through other architectures, how we're going to sort of eliminate that and reduce that cost that we're sort of paying right now. And I mentioned validation, but validation actually occurs not at the collector. So it doesn't occur at the edge, it actually occurs much later in the pipeline. And that was a conscious design choice, because what we wanted to be able to do was make sure that teams felt confident that the data was persisted even if it was invalid data. And we would then give them hooks and means to go back and reprocess that data and update it and fix it before it makes its way into our data lake. Now the challenge is that it first occurs far later in the ecosystem. So it's after we've replicated back to central, it now gets put onto a dead letter queue, and game teams then need to go read off that dead letter queue, reprocess their events, and make sure that they get into the data lake. And that occurring much later means that teams may go a day or two before they recognize that they have data flowing into the system, and then that's just a lot to reprocess, which has downstream effects where ETLs now have to be rerun because the data wasn't in there, and there's just lots of knock-on effects to that. But we were still able to build great things on top of this. And so just like before with the Honu system, I want to call out a couple examples where we've leveraged the analytics platform to deliver player value. The first is Valorant matchmaking. So when Valorant came out, the skill estimation team, or the tool, the skill estimation models were built on top of the data flowing in to the analytics platform. What that means is that we could use internal play tests and early play tests with players in order to gather data to refine those skill estimation models. And that allowed us to get a good handle on it, so when we launched Valorant, our players were immediately able to get into challenging and competitive games. Additionally, with Valorant, as we prepared to roll it out and onboard more players into the closed beta, we leveraged Twitch and player viewership in Twitch to grant players access to Valorant before it was generally available. So players would log into Twitch, they would go find their favorite streamer who would be streaming Valorant, they would spend time watching that, and then after so much time, they would receive their beta key, and those heartbeats and those time watching all flew through our analytics platform. And then lastly, we work closely with Legends of Runeterra team, which is our trading card game, to ensure that we launch with balanced sets. And we would monitor play and win rates of our decks through our metagame analysis, again, powered by the analytics platform. So now we found ourselves with two systems to maintain. One system powers League of Legends and Teamfight Tactics. The other system powers Valorant and Legends of Runeterra. And so I couldn't help but think of XKCD at this time and Randall Munroe's uncanny ability to apply to many parts of my day job. So there happens to be a very famous XKCD comic where he talks about competing standards, and then the proposal is to write another standard, and now you have 13 competing standards. And in fact, that's kind of what we did here. So we started with an ingestion system, we wanted another one, and then we really wanted to collapse League of Legends and Teamfight Tactics onto the new analytics platform. But when we worked with the League development teams, moving from schematized or unschematized into schematized world was going to take a whole lot of work and would be a very large burden for them. At that time, we had tens of services running. All of them would need to be redeployed globally. They would need to roll out strategy. It was just not a good path forward for them. And so, not to mention, once we actually moved them over, then we had a whole slew of ETLs and data systems that relied on data in one format that would now need to be updated and changed to read from the other format. So there are things that we liked about AP, and we saw opportunities to improve Honu by leveraging Kafka and other sort of decisions that we made. And so that's what led to our next slide, which is fixing the plane mid-flight. And so in this case, what we wanted to do was come back and improve Honu and make it more modern and change some of those assumptions we had since 2012. And I'll let Karthik walk us through that new architecture.
So if you remember in the initial architecture diagram for Honu, we talked about how there's a local file system for the game servers and the in-game processing engines that we are on the Riot's data center. And then all the data was being uploaded to S3, and we had EMR jobs to demux that data. That's the initial architecture. So now, in the revised architecture, we're introducing Kafka as a streaming mechanism for data throughout the ecosystem. So on the players and services side, it is still the same contract. What happens is the game servers and all the microservices, they're talking to the Honu collector, right? And then within the Honu collector interface, we introduced Kafka running locally to start putting the data onto the Kafka ecosystem. And from here, we leveraged Kafka Connect to replicate the Kafka system to the nearest AWS region, where we have MSK, which is Amazon Managed Kafka Service, running as the primary backbone for the Honu system. So from here, we are moving, and as they're moving more and more data, microservices, and game servers into AWS regions around the world, we saw that it was easy for us to connect that ecosystem into AWS MSK. From here, the downstream was pretty straightforward. We were moving all of the data from MSK into Spark, and we had Spark jobs that were reading from this data. And what happened was we took that data and started persisting that data into Delta Lake, as Wes mentioned earlier. So in this ecosystem, now we have had data from all the way back from 2013, plus the newly generated data that we're seeing from all around the world. So now what we did was we used Glue Metastore to have the metadata information for the newly generated data. And for the older data, we used the Hive Metastore. So engineers had to use a lot of complex views, logics, and queries to make sure that they're querying data both on the Hive Metastore and also on the Glue Metastore. Yeah.
So one of the key features of these new changes is that we wanted to make sure that players were not impacted to any changes we made. We also wanted to ensure that game teams were not impacted and they didn't have to make any changes. So as Karthik mentioned, we preserved that Honu contract, and we actually changed the plane out mid-flight so that we could dark launch this new Honu collector alongside our existing Honu collectors. We gathered data for weeks and up to a month, and then sort of validated that there was no loss of data in transit. All the data that we gathered matched the data that we would have gathered from Honu before we actually flipped the switch and turned off the old ecosystem. Now the good news is that succeeded. We didn't impact players. Those teams were not impacted as well. We did discover things along the way. I won't pretend that this was perfect. It did take some work in order to sort of figure it all out in the last few minutes. As we mentioned, we preserved that Honu contract. What does that really mean? In the sense that we have services that handle things like matchmaking, so that's how you get into League of Legends. We have socials, services that are managing chat and how you're interacting with other players in the game. We've got player dynamics, who's helping incentivize good behavior and punishing bad behavior. And then we have just game telemetry coming out of those game servers. All of those have been instrumented over the last 10 years to actually talk to a Honu collector. That interface had to stay the same so that those teams could continue to operate. And then the last feature of this new system is that it was an improved performance. As we mentioned, we removed that need to run EMR batch jobs to actually condense and aggregate many small files into larger files. Now we can go directly from the microservices into the data lake and let analysts query the data within 15 minutes of it being created. And so that was a huge win for those analysts. Reports were now updating much more quickly, and they didn't have to wait 6 to 12 hours before they could make decisions about how feature rollouts and those sorts of things were progressing. So how much data are we now processing? We are processing upwards of 500,000 events per second. And despite the title saying 20 terabytes of data, we've grown a little bit. Our games have been successful, and now we're processing upwards of 75 terabytes of data every day and continuing to grow our data consumption. So to recap, the comparison of Honu versus the analytics platform. So Honu, as I mentioned, is powering League of Legends and Teamfight Tactics because they have a shared game engine. The analytics platform is powering Valorant and Legends of Runeterra as that new next-gen sort of system that we built for all future Riot games. And so when it comes to schema, as I mentioned, Honu is schemaless, AP sort of enforces schema. When it comes to Kafka, they are both now running on top of Kafka. No more writing files and uploading to S3. Neither of them are able to produce unique topics. Both of them are still moving from a fire hose method where all the data is flowing over a single topic. And streaming is possible off the analytics platform, and technically it's possible off Honu. Now, one of the things we didn't dive deep into is, but when Honu writes its data, it actually writes everything into one very, very large table that has every message from every region all in the same table. And the view handles the heavy load of finding the right partitions and making those queries performant. So technically, you could stream off of these Delta tables. I don't know if you'd really want to because you're processing way more data than you would intend. And then lastly, neither of them support regional processing. So here our Kafkas are still locked behind the data team's capabilities, and game teams are not able to come in and work directly with those Kafka instances. So here we go again. Even though we made the changes, we're still running two ingestion pipelines, and neither one of them satisfies a growing concern that we have. And that is, how do we actually handle the current political climate where data will need to stay and not be centralized? And so there the idea is, can we keep European data in Europe? Can we keep American data in America? And so on and so forth. And so what we really want to do is unlock our event-driven capabilities, as well as in-region processing of messages on single topics that teams can subscribe to. This will allow our ingestion pipelines to be used by more teams at Riot and not be limited to just our data teams. So with that, we set out to build one event bus to rule them all. And we built that to tackle the things that I just addressed on the previous slide, but also to sort of simplify and manage our auto-scaling compute and storage. We want better cost transparency and controls so that teams, each game knows how much data they're sending through, how much they're costing Riot sending that data through, and make sure that we're spending our player money wisely. We're going to want to satisfy it with event contract topic discovery. So think schema registry. We want to be able to publish these topics and let other teams subscribe to them. We want declarative event routing. So we want to be able to say, take this message and send it where we want it, as well as dynamic event routing where the event can sort of say where it wants to go. And then last, we want to make sure it's easy for game teams who happen to still be in data centers to integrate with the tools that we have. And so with that, I'm going to hand off to Karthik again to walk through the architecture.
So the new architecture is called Rebus, which is a shortened version for Riot Event Bus. And the core, the atomic unit for grouping these resources, we call it as a Rebus hub. So some of these familiar players that we have seen earlier in our presentation are here. So we have our Rebus collectors. We have our MSK Kafka as our event bus. And we also introduced a new collector, and this would allow us to define open source eventing standards. So what this means is we could leverage Proto to define our schemas and our cloud events as schemas within our ecosystem. We also introduced a schema registry where teams publish proto-buff schemas for validation and consumption. And we now support teams consuming from a Rebus hub down into various data processing systems. And we also introduced two additional components into our hub. The first is a Kafka Connect. And what this does is this will allow us to connect the Rebus hubs from a central and a satellite location. And these can be deployed by any team using various region configurations. So with each hub at a minimum is scoped to one use case. Like, for example, League of Legends, right? If they want to deploy to a US West shard, they would rely on Kafka Connect and a declarative group to now move messages between these hubs. And the warehouse router now stores and handles all of the data into our data lake for all the downstream consumption by scientists, engineers, and analysts.
So some of the key things that we wanted to unlock with the Riot Event Bus hubs is we want to really sort of provide a mechanism for Riot teams to do event-driven systems from the get-go without having to worry about staffing their teams with Kafka experts in order to make sure that Kafka's up and running. So Data was going to tank that for them and make sure that all the Kafkas were available and that all they had to worry about is publishing and subscribing to those systems. In the example that I give here, League of Legends has a game end event. They publish it to the Rebus collector, and that gets put onto Kafka. So now Clash, which is our tournament system, can subscribe to those events, and when that event comes in, it can know it can advance the tournament that's being played by the players, rather than doing API REST calls. Additionally, we can also have something like our honor system, which is on the top right, listening to that event and deciding to do follow-up computation based on whether or not you were honorable or maybe had a bad day in League of Legends, and so they can take action based on that. We also wanted to ensure that teams were isolated. So this is one of the biggest things that our teams talked about, is that we've had this thundering herd problem where a giant spike in Valorant may lead to a service falling over, which then would impact other game teams like League of Legends and Legends Runeterra. And so what we wanted to ensure was that these Rebus hubs were deployed in such a way that teams couldn't take each other out. And so a giant spike in League of Legends that may lead to an outage would only affect League of Legends and not affect Valorant or other game teams. This also allowed teams to sort of maintain ownership of what is in their Rebus hub, and sort of handle that routing and make sure that everything's running properly. And as Karthik sort of alluded to, this routing mechanism is pretty critical for our central player platform team. So that central player platform team runs sort of the core backbone, which is our accounts, some of the matchmaking stuff, and they sort of are expanding those things that are shared by all the Riot games. Now, each game team may have their own Rebus hub where they publish their events on, but player platform may need to subscribe to those events in order to update things that you own, or provide you with other capabilities. And so the routing allows us to take that message, send it over to the player platform Rebus hub, and vice versa. And then lastly, we can deploy these Rebus hubs at any granularity. We support regions, so if you want to say deploy a Europe Rebus hub, we support shards. So here think of EU West versus EU North, if you're familiar with League of Legends regions. So we have different servers satisfying different needs within Europe. And so we sort of support both of those deployment models, and then the routing between them. So going back to that picture that we showed earlier, the key thing that we wanted to highlight here is we now have schema with protobuf, and you may be wondering, okay, you switched schema again. So our engineers were not a huge fan of JSON schema, and in fact we wanted to, it's all about lowering the bar to make sure it's easy for our engineers to publish data into our ecosystem, and Proto was one that we felt they should be able to adopt much more easily. We are all running Kafka now, and Rebus is actually running with unique topics. So here, game teams can subscribe just to the information that they need. We're also unlocking streaming capabilities, so now teams can subscribe where they are and write anything from Flink, K-streams, Spark structured streaming, or just REST API callbacks for getting data off the Rebus hub. And then the last one, we've actually unlocked regional processing. So now teams can subscribe in region. We don't have that global sort of replication back, so our costs are going to be less. And we are on our way to sort of unlocking data marts that live in region rather than one central data warehouse. So this system is live and in production and has already started unlocking some player value. So if you were here earlier and got to see the league opening ceremony or hear me talk about our esports, this year and previous years we ship with a pick'em. So think of this like the NCAA March Madness. Everyone picks their bracket. We have that for everyone trying to get to the League of Legends World Championship. And if you pick right, you earn rewards, and all of that rewards sort of granting and capability was powered by Rebus. We also have a big push to enable two-factor authentication to protect our players' accounts. We want to make sure that there are not takeovers of their accounts, that they're safe, and so enabling two-factor authentication is something that we've worked on for a very long time. And sort of to incentivize players to come in and protect their accounts, we offered rewards for them to do it. And that reward was sort of powered by Rebus hubs. And then lastly, our central player dynamics team has been one of the early adopters of Rebus. They use it from anything from like providing punishments to a player who's had a bad day and may have been a little disruptive in game, to honor awards and sort of dropping things that incentivize that good behavior. And so all of those techniques are live in production today, and so we are starting to see some adoption of Rebus. So to recap, we started in 2012 with Honu. This moved us away from database scraping and actually allowed us to empower engineers to start submitting data into our data ecosystem and arriving back where analysts and scientists can build on top of it. We addressed some of those problems with our analytics platform. We wanted to increase the knowability of our data. We also wanted to increase the stability of the system with the changes that we made for the analytics platform. We took what we learned with the analytics platform and went back and revisited the Honu and now moved it onto MSK. So now we have the same sort of Kafka-powered experience on both platforms. And then we've moved forward with Rebus, where we're trying to unlock far more event-driven system capabilities for Riot. And so right now we're at that point where we have 3 ingestion pipelines that we have running in production. Of course, you're going to see me say something about Randall Monroe and XKCD, but we hope that we will reduce this over time. And that's where we move into what's next. So what's coming? So on our roadmap, one of the first things we want to do is onboard additional teams onto Rebus. So really bring them on, start expanding the use cases that are supported by the Riot Event Bus, and start gathering a lot of value with it. At the same time, we're going to investigate consolidation of pipelines. So we want to make sure that I'm not running 3 distinct pipelines in production in perpetuity. So what does that look like? Odds are it's going to look like fixing the plane mid-flight that you saw with Honu over MSK, or it's going to look like something where we have one collector that satisfies all 3 collector interfaces, and then we just have to sort of migrate the backends over to support it. But that work will be ongoing in this year as we sort of try to figure out how we grow Rebus and consolidate all these workloads. We're going to focus on some improvements through data warehousing and data lake capabilities. So here, we haven't talked a whole lot about how analysts are working with the backend system, but we want queries to be more performant. We want our analysts and scientists to be able to get results far more quickly than it currently takes them. And I think a lot of our time is spent here sort of building ETLs, orchestrating those ETLs, and we want to clean that up and standardize it more. We're going to investigate regional data lakes. Here the idea is, can I leave the data in region and not bring it back to a central location? With that, it also means that we're going to need to take all of the queries that our analysts write and federate them out to the regional data lakes, get the results back, aggregate them, and bring them back centrally so that they can get the view of the world that they want. Now, we've got a leg up on this for our ML use cases. For our machine learning use cases, we already sort of are breaking apart the models by the region in which they are trained on. And so the idea here is that Korean players may play League of Legends very differently than North American players. So we want to be able to make sure that those models take into account those regional differences and provide the best possible player experiences for all of our players. And then lastly, we're going to increase investment into our ML ops. So as I mentioned through several of the examples of player value that we've generated, we are getting value out of our data ecosystem. We are building models on top of it, though we don't have a good standard way to do ML ops at Riot. We want to make it easy for teams to go from idea to model to production, but then also add in that capability to track how well their model is performing in production and go from there. So this is going to be a big investment. We're going to need to sort of work with teams across all of Riot to better understand how they're doing it, make sure that we come up with good standards that support all of them, and move forward. And lastly, I'll leave it with Karthik.
Yeah, just want to leave you the quote by Richard Feynman. All the work that you've seen that's happened with Riot and all the other customers, everything happens by willingness to learn and solve problems. So all the thing that we did was based on the data, the proof of concepts, using your data to make sure the use case is right for you. It's the right tool for the right job. And just want to end the session with that quote from Richard Feynman. And having said that, thank you very much.